Hey guys, we're back with the notes for 6.2. Today we're going to be solving systems of equations algebraically. Now, the topics that we're going to be doing on this front page, you did do in Algebra 1. We're going to be solving them with substitution and solving with elimination. Now, you're going to have to make this decision on your own. Most of the time, I'm not going to tell you which kind to use, so let's talk about a couple strategies for you to decide which one. We're going to use substitution whenever it is very clear that I can get the x by itself or the y by itself in one or more of the equations. We're going to use elimination whenever the variables have coefficients with them and it's not convenient to get one by itself, but you also would have to have them stacked up. So see how the a's line up, b's line up, equal constants line up? Same thing here. The x's line up, y's line up, equals, and constants. That's how we're going to know to use elimination. So we're going to walk through we're going to walk through a couple of each of these, show you what the process looks like, show you what an answer looks like, and then we're going to let you kind of choose two on the back to decide which method you would use. We're going to do one application problem, which means you're going to be writing the equation from a word problem and solving it, and then we're going to spice it up and see how you do throwing a quadratic in the mix, okay? All right, let's go ahead and start number one. Number one tells you straight up we are going to do substitutions. Let's talk about what that looks like. First of all, I'm going to try to decide if there's an x equals or a y equals that I can get by itself. Most of you guys are going to see that I have an x and a y kind of without a constant in front of it, a coefficient in front of it. The x is positive, the y is negative. So I'm going to try to get this x by itself as the most convenient method. All right, in order to do that, that's going to require moving this 3y to the other side. That's going to give me my x equals by itself, and then 3y plus 16, okay? Now that I know what x equals, I'm going to be able to take this part, this whole x equals, and I'm going to be able to replace it in my x value. Now, I'm not getting rid of the 4, so maybe I should make that a little bit smaller. I'm only replacing the x, okay? So if I write that out, I have 4. I'm replacing the x value with that 3y plus 16 in the other equation, and I'm going to just copy down the rest of it. Minus y equals 9. Now, this is a very Algebra 1 baby question. We're going to distribute. So 12y plus 64 minus y equals 9. Combining our like terms give me 11y plus 64 equals 9. If I subtract that 64 from both sides, I get a negative 55. And if I divide both sides by 11, my y value is a negative 5. Now, we know from a lot of solving in this unit that our solutions to a system should be a point. So think about it this way. Right now, all I have is the y value. I still need to find the x value. So what you're going to do is substitute one more time. I would always encourage you to substitute back in where you started because that's going to be the easiest location. If I take this y and I plug it back in here, then I don't have to do any solving. All I have to do is simplify. And by that I mean if I plug in negative 5 for y, 3 times negative 5 is a negative 15 plus 16 gives me a positive 1. That 1 finishes out my solution. Okay? All right, if you need to pause, copy any of that down, go ahead. We are moving on to the bottom. Let's talk about some elimination. Okay, when it comes to elimination, here's the goal. Don't write this down. You are trying to find something like 2x and a minus 2x. Same number, different signs that can cancel. Another option would be on the top. If you had something like a negative 4y and a plus 4y and they cancel, that would be convenient. We are adding the lines together, so they need to have opposite signs. Now, if you look at a problem like the first one, and I notice that the a's don't cancel and the b's don't cancel, then I have to make it cancel. Sometimes you get lucky. Sometimes this is a 6, and you could say, oh yeah, 3 goes into 6 2 times. But in this case, that doesn't work. 3 doesn't go into 5, 5 doesn't go into 3, 4 doesn't go into 5, and 5 doesn't go into 4. So we're going to have to find what we used to call the least common multiple that both of those numbers will go into. So we have two options. We can either make the a's cancel by multiplying them up to 15, or we can make the b's cancel by multiplying them up to a 20. Now, I'm going to choose the b's, and I'll tell you why. The signs are already different, which means I don't have to mess with the signs of multiplying a positive and a negative. I'm going to multiply the top row by a 5, which guarantees my b's turn into 20b. Let's do that real quick. So if I rewrite this next door, it's going to say 25a plus 20b equals 55. Noticing I am distributing that 5 all the way through to everybody. We're going to do the same thing on the bottom equation, but for this to turn into a negative 20, that means I need to multiply by 4. All right, distribute all the way through. We're going to have 12a minus 20b equals a negative, what is that, 92. All right. Again, if you ever need to pause, copy this down, go ahead and do that. We're going to move forward. Once I have my two new equations, you should very clearly have something that cancels out. And what we are going to do is add these two lines together to make one equation with one variable. Okay? So 25a's plus 12a's gives us 37a's. 55 and a negative 92 gives us negative 37, which makes for some very easy division. Divide both sides by 37 gives us a negative 1. Now that's great, but that only gives us the a part. Okay, alphabetically a would come first. Now I need to find my b part. You have 4 different options here. You can take this a value and plug it in here, 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 or here. Totally up to you. My suggestion is always find the easiest equation to work with. For me, I would use this top guy because he's not going to have any negatives in it, okay? All right, so if I use that one, I'm plugging this up into this a. So 5 times the negative 1 plus 4b equals 11. 5 and a negative 1 makes a negative 5. If we, that's a 4b. If we add 5 to both sides, that gives us 16. Divide by 4 gives me 4, which means that my total final answer is negative 1, comma 4. Remember, we should always write these alphabetically. So just like x comes before y, a would come before b. Okay? If you need to pause that, copy anything down, do that now. We're going to go to problem 2. All right, now I told you we need to make the numbers cancel, and sometimes you get lucky. If I look at this problem, I get lucky right away. 2 doesn't go into 5, but 3 goes into 6. I also get lucky because they already have different signs on them. So the only thing I need to do is turn this number into a negative 6. How would I do that? I would have to multiply his row by a 2. So let's move these over. We're going to end up with 10x minus 6y equals a negative 6. The bottom row doesn't have to change. I'm going to keep him. 2x plus 6y, plus 6y equals 0. Very clearly, the y's are going to cancel. They eliminate positive 6 and negative 6. And again, remember that we are adding together what's left. 10x and 2x makes 12x. Negative 6 plus 0 makes a negative 6. Now be really careful. A lot of you are going to be tempted to say that x is a negative 2, and it's not. When you get x by itself, that means you're canceling off the 12. That means my x is a negative 1/2. Nobody likes fractions. It's not convenient, but that is our answer for x, okay? All right, so let's go ahead and get this guy set up. My x is a negative 1/2. We are trying to find the y. This one is very, very tricky, and so that you don't think that we ended up with the wrong answer, or so that you can see how it works on both of them, I want to use both of these, okay? I'm going to show you plugging this x into both equations so you know it doesn't matter, okay? My suggestion would be you listen while I'm going over it, and then you copy at the end by pausing, okay? All right, so first problem we would write out 5 times a negative 1/2 minus 3y equals a negative 3. Other option would be 2 times a negative 1/2 plus 6y equals 0, okay? Let's do the easier one first. 2 times a negative 1/2 is easily negative 1. Oops, 6y equals 0. We'd add 1 to both sides. Gives us 6y equals 1. Divide by 6 gives us positive 1/6. Now you're like, oh, well, that was fine. 2 canceled with the 1/2. But what if I had done a 5? Okay, this one's going to be a little bit trickier. We're going to need to convert everything to fractions so we can work with it, okay? So 5 times a negative 1/2 is negative 5/2. no problem. But right now, I'm going to make everything halves. Okay, so if I have 3 holes, 1, 2, 3 holes, how many halves do I have? Should have 1, 2, 3, 4, 5, and 6. So I'm going to convert those 3's into halves. So negative 6 halves of y and negative 6 halves as my constant. Okay, we're going to add that negative 5 over 2 to both sides. Remember that when you have common denominators like these 2's right here, all we have to do is add the numerator. So negative 6 plus 5 is a negative 1, like negative 1 half. Bring down the negative 6 halves. And then if we're ready to simplify this out, we can multiply by 2 on both sides. Get rid of those 2's. Gives me negative 6y equals a negative 1. Finally, divide both sides by negative 6. Gives me a positive 1/6, which is what we wanted that whole time. That's what we decided on the other one. So again, it does not matter which place you plug it into or which equation you plug it into. All that matters is that you simplify correctly. Okay? If you need to pause that screen, go ahead and copy anything you missed. We're going to move on to the back page. All right, on the back page, I'd like you to pause and try these top 2 equations. We're going to talk about which method you would use for each of them. My suggestion is because this x is pretty much alone and you can isolate it by itself, I would use substitution for this problem. You could use elimination by multiplying it out either way, that's fine. You could do elimination if you wanted to multiply this row by a 2. You could make the 4 y's cancel, that's an option. But I want you to decide which one's best for you and use it to solve that first problem. Okay, pause the screen, do so now. Wonderful. Okay, the answer you should have gotten is negative 8, 0. This should be your x and this should be your y. If you did not get that answer, I would encourage you go back and listen to the first problem in these notes again. Okay? All right, will you pause for just a second and try the second question? Second question, I would definitely use substitution because it's not lined up. I would move this 1/4 to the other side, getting your y equals, and then you can plug it in where the y is. Why don't you pause for just a second and try that second equation? Wonderful. You should end up with 4, 0, where your x is a 4 and your y is a 0. Remember, to show that your notes are completely done, you do need to have work, like show your work out on these problems to show that you worked it out, okay? All right, let's go ahead and talk about the application problems. Okay, application problems means that you're going to not only write the equation, but you're also going to solve it. So let's go ahead and read through this one together. It says the hair salon receives a shipment of 84 bottles of hair conditioner to use and sell to customers. The 2 types of conditioners, so this tells me there's 2 variables right now, are type A and type B. Okay, so right now, if I know I have A and B, and then I got a total of 84 bottles, total means we add, and all the bottles together makes 84 bottles. That's my first equation, nothing fancy. It says type A, which is used for regular hair, and type B, which is used for frizzy hair. Type A costs $6.50 per bottle, okay? So $6.50 multiplied by however many bottles I got. Type B was $8.25 per bottle, so times however many bottles I got. The hair salon's invoice for the conditioner was $588, so $588. How many of each type of conditioner are there in the shipment? Okay, so not only are we solving for this like a point, but we are going to want to have units on these word problems because it's given to us in words, okay? All right, let's go ahead and start this problem out. I noticed right away that A's come first, plus B's, and then my equal sign. I'm going to treat this like elimination because it's already stacked up that way, okay? All right, on this problem, it does not matter who you cancel. You could cancel out the A's or the B's. For me, to keep my number smaller, it makes more sense to multiply by 6.5 than to multiply by 8.25, okay? So I'm going to multiply by 6.5, but the trigger here is I have to make sure it's a negative 6.5 here. Oops, let me see if I can make that negative. There we go. Has to be a negative because if it's not negative, they're not going to cancel. All right, let's write our new equation over here. So negative 6.5a, let me make that 0.50 A minus 6.50B equals negative 546. And again, that's just multiplying negative 6.5 times 84. Bottom equation didn't change. I'm going to keep him exactly the same. 6.50A plus 8.25B equals 588. Remember, if I'm going too fast, you can always pause it, copy it down, or listen to it again. All right, we have forced the A's to cancel. So now what I'm going to do is add up what's left. I'm going to zoom in for just a second so we can fit this. Negative 6.5 plus 8.25 gives us 1.75B. Negative 546 plus 588 gives us 42. And if I divide both sides by 1.75, my B value is going to come out to give me 24 type B bottles. And I am writing my units, type B bottles. Okay, zoom out real quick. Now, right now we only have one type, but the shortcut here is that I know that there's 84 total, remember? So if I know that there are 84 total, and I subtract off the 24 that are type Bs, then I know that I must have 60 type A bottles remaining. So that is my A equals. Okay? All right, if you need to pause that for just a second, go ahead and copy what you see. Otherwise, we're going to do one more problem, and this one is going to be quadratic. All right, last problem we're going to do together, solving a linear with a quadratic algebraically. All right, so right now I notice both of these say y equals. So we are going to take this top piece and we're going to replace it into the second y. All right, let's write down what we would have. We would have x squared minus 2x minus 6 equals 4x plus 10. Now remember when we solve quadratics, two rules. Number one, make sure the x squared is negative. Number two, make sure it equals 0. Okay, so I'm going to move the 4x over to this side because x squared is already positive. And I'm going to move the 10 over to this side. So we have x squared minus 6x because I subtracted 4 minus 16 because I subtracted 10 equals 0. This one I'm going to check to factor first because I have a regular x. I'm looking for, is there any way I could multiply to make a negative 16 and add up to a negative 6? And that's one that I can do pretty easily. So if I'm thinking factors of 16, I've got 2 and 8, or 4 and 4, or 1 and 16. I need the signs to be different. So if I made the 8 negative, so x plus 2 and x minus 8, that would give me a negative 6. Okay? Remember that when we solve by factoring and you switch to your x equals, you have to change your sign. So x equals a negative 2 because it said x plus 2, and x equals a positive 8 because it was a minus 8. Okay? Remember, both of your answers, because you have two of them, both of them need to be points. So if I got two different x's, I have to plug both of those in to get my y's. Okay? All right, I'm going to plug both of these in to this bottom equation. That way I don't have to deal with squareds and exponents and everything. Okay? All right, let's do the first one. If I plug in y equals 4 times a negative 2 plus 10. 4 times negative 2 gives me negative 8. Plus 10 would give me a positive 2. So that one goes with the first guy. Second one is if I had y equals 4 times 8 plus 10. 4 times 8 gives me 32. Plus 10 gives me 42. So 42 goes with the 8. Okay, so because I had two x's, I have to plug it in to have their two matching y values. If you need to pause that screen for just a second, go ahead and copy what you need. We're going to have you attempt 4 problems on the bottom. So problem 14, 15, 17, and 18. That numbering is terrible. I'm so sorry. I'm going to ask that you try those on a scratch sheet of paper and then check your work with the answers. Okay? You can cheat this if you'd like, but this is a chance for you to see if you're going to have questions before coming to class. Okay? All right, so problems 14, 15, 17, and 18, try them on your own, and then I'm going to show you the answers. Okay, you should pause now if you haven't already paused. All right, let me go ahead and erase what the answers look like. I'm going to zoom into each one real quick. Okay, there is your answer to the first one. It is quadratic. I solved it by factoring. X was 6 and 9. Plugged them both in to find their y's. Problem 17 is a little more complicated. I had to make the x squared positive, so I moved everything to the right. This one did not factor, so we had to do quadratic formula. If you left it as 3 plus or minus square root 41 over 4, that's great. If you move to decimals, that's fine too. Let's look at number 15. Number 15 was a very easy factor. Multiply to 70, add up to 17, that's 7 and 10. 2 x's, plug them in to get 2 different y's. Last one. Problem 18, you're going to need to swing and divide to factor it, but you can still factor it. I would leave them in fractions. I would not try to change those to decimals. Okay? All right, hopefully you did well on those. If you did not, if you had trouble with those 4 practice problems, that's what I would encourage you to ask questions about when we get to class. All right?